All right, boys and girls, welcome back to the drive-thru. Hope everyone's having a wonderful Beat Mason day, a special Beat Mason version of the drive-thru, sponsored by the deli. Hungry? Stop by the deli. Get yourself a Comet sandwich with some extra Mason sauce and destroy that thing in 2 bites. Okay, this is the biggest lesson of the year so far. Okay, 3 shortcuts to triangle congruence. I can promise you that all of these will be on your next standardized test. Okay, so that for you guys is the AIR test, A-I-R. Okay, all right, so what we're doing here to start is the last time we'll ever have to do this. So just bear with me here. Rather than writing my givens up here, I just wrote them all out here. Okay, so we are given that H is the midpoint of OT and MI, that MO is congruent to IT, so I'll mark that because we have stated that they're congruent, okay? I'm not going to mark them until I state that they're congruent. Angle 1, sorry, I checked that wrong. Angle MOH is congruent to ITH. This one is congruent to that one. Angle 1 is complementary to OHM, and angle 2 is complementary to THI. All of that is our given information. Okay. So, any idea where we want to go next? Let's use our definition of midpoint. So what can we say? OH is congruent to TH, and MH is congruent to IH. Now you could reverse the order of those letters because segments are reversible, okay? And what would be my reason for that? Definition of midpoint, very good. Okay, now that I've stated that they're congruent, I'm going to mark them. So I said that this was congruent to that, and this one was congruent to that one, okay? All right. Where do I go next? Yeah, Jack? I can't say that yet, but I know exactly what you're going to say. First, I have to say OHM. I'm going to call on you in just a second again, Jack. OHM is congruent to THI by vertical angles. Theorem. Okay? Jack? Now I can say that angle 1 is congruent to angle 2. Okay? I want you guys to look closely and understand why Jack said I can say that. Why can I say that? Johnny?
Because OH and THI are congruent, and so if one is to a complementary to congruent angles.
And if 2 angles are complementary to congruent angles, and those 2 angles are? Excellent. That's called the congruent complements theorem. Okay? Let's mark that. I'll mark it with 3 lines. Okay, now I look at my picture. Have I proved that all 6 parts of the triangle on the left are congruent to all 6 parts on the triangle on the right? Okay, now I got to make sure that I write my congruent statement in the proper order. So, if I said that triangle MOH was congruent to, let's scroll back up and look at our picture. I know, just ignore this for a second, okay? What order do I have to go in? If I went M, O, H, you got to follow the same order of the angles. So what angle is angle M congruent to? Angle I, you got to look at the marks. That's why you mark them properly. Okay, so what is O congruent to? T, so it's going to be ITH. So the first thing I want you to understand, the order of this is very important. This is telling you that angle M is congruent to what? Angle I, by the order, okay? So for this, my reason would be definition of congruent triangle. You'll never have to use it again if you've paid close attention to the rest of the notes. So what I'm telling you is that what we're doing today is learning 3 methods to prove triangles congruent where we don't have to get all 6 things, because that's a real big pain. Time out. Untime. Check this out. Oh, whoa. All right, so here's your first one. The SSS postulate. Notice it's a postulate. It's not a theorem. Postulates cannot be proven. This is true, and no one on the history of the earth has figured out a way to prove it. Okay? So here's what it says. If I had a triangle that was, let's say, 3 inches, 4 inches, and 5 inches for my sides, okay? And I challenged you guys to make a triangle whose sides were 3 inches, 4 inches, and 5 inches. You would make the exact same triangle. It could be reflected, so it could look like this. Okay? If you made the triangle that was 3 inches, 4 inches, and 5 inches, it would be completely congruent to mine. Meaning, if we know that the side lengths of your triangle are congruent to the corresponding side lengths of my triangle, so we have this. If we know all that information is true, then we could state that these 2 triangles are congruent by the SSS postulate. We don't even need to know anything about the angles. Are you down with that? So what's the first shortcut? We just call it SSS. Okay? So far, so good? Okay, the next one is the SAS postulate. Now this is very wordy, so I'm going to explain to you what this included angle means. Okay? If 2 sides and the angle included between those sides of one triangle are congruent to the corresponding sides and angle of another triangle, then those 2 triangles are congruent, okay? So here's what I want you to imagine. I want you to imagine an X. Okay? An X. Now, what do we know about the angle, the measure of angle 1 compared to the measure of angle 2? What do we know about those 2 things? They're congruent because of? All right, so we got our angle. Now look, what if I told you that this side was the exact same length as this side, and that this side was the same length as that side? Now what I want you to imagine is that I'm about ready to connect those missing segments, okay? What do you think will be true about those triangles that I draw? Can anyone envision it? They're congruent. Let's take a look. See that triangle on the left? Doesn't it look congruent to the triangle on the right? Looks like a rotation of some sort. Can you see that? So here's what we learned. We don't need 6 parts. If we have 2 sides of one triangle congruent to 2 corresponding sides of another triangle, and we know that the angle in between those sides, it's got to be the angle in between, then we know those triangles are congruent. By what? By SAS. I want you to know something. SAS works. ASS does not. That's an easy way to remember. Not allowed to say that in school. Okay? There is no AS theorem. It's Sorry, this is the internet. It's not school. There's a difference. There's a SAS, but there's no ASS. You got to remember that. The order of these things matter. The angle has to be between the sides. Okay? We got one more. Alright, so if you understood the SAS postulate, then you will understand the ASA postulate. It says, if two angles and the side included between those angles, so, let's see. Okay, so here we have two angles from the bottom triangle are congruent to two corresponding angles from the top triangle. And we've got that the segment that's in between the angles is congruent to this segment that's in between the angles. Then, by the ASA postulate, the ASAP postulate, part of the ASAP Rocky and ASAP Ferb family, the ASAP postulate says that these two triangles are congruent. You down? Alright, so let's practice. How could we say that these two triangles are congruent, and what would be our reason? We can say that triangle RAF is congruent. Now, what angle is R congruent to? K. What angle is A congruent to? A. And what angle is F congruent to? N. So RAF is congruent to KAN, and my reason would be the ASA postulate. Down? I'll get you started. Okay, let's try another one. Here. Triangle val. Now, this is a little harder, so we got to check. Segment VA is congruent to, let's see, we start at 1 and go through the 3. Start at 1, so E, S, J. Okay, now, oh dear. Okay. So, let's make sure I got this right. VL is congruent to EJ. That's true. AL is congruent to SJ. AL, SJ. Okay, we're good. My reason would be SSS postulate. Okay? Alright, now it doesn't look like we have 3 pieces of information. It looks like we don't have enough to prove these triangles congruent. But if we remember vertical angles, now we can say that triangle GRA is congruent to. Now this is a little interesting. We have a little more leeway here because these are isosceles triangles. So the order can have a couple different options. But we can just go with CEA. Let's check it. Is GR congruent to CE? It looks like it. We haven't proven it. Is GA congruent to CA? Yes. Is EA congruent to RA? Yes. So this is true by the SAS postulate. And all you guys, a lot of you guys are full of SAS. Right, Jenny? That's right. Okay? All right. Now, let's see what this will look like in a proof. Okay? So, given that SV, let's get some little better notation on here. And VS. Okay. Given that SV bisects angle TSB and VS bisects angle TVB, prove that the top triangle is congruent to the bottom triangle. So let's state our givens. Ray SV bisects angle TSB. Ray VS bisects angle TVB. Okay? Now let's mark it after we... So, what will that result in? Well, now we can say that angle TSV is congruent to angle BSV. And at the same time, we can say that angle TBS is congruent to angle BVS. And what would my reason for that be, Class A? Definition of bisect. Excellent. Okay, so look what we have here. We've got this is this. We've got that is that. It seems like we need another piece of information. So now this is where you start to think. Well, there is no angle, angle, angle. There's an angle, side angle. So what I need to do is prove that the side in between those angles are congruent to each other. Well, this works out really well. This transfers just over from last night's homework. So what would allow me to say that SV is congruent to SV? Magna? That's right. You did your homework, kiddo. Reflexive property. So now we said that this was congruent to itself, and now we can finish by saying that triangle TSV is congruent to, I got to be careful here, TSV, triangle BSV. And the reason? Okay, and our reason would be the ASA, right? ASA postulate, also known as the ASAP postulate, and we are done. Boom!